Another warm welcome to everyone who has just joined. So it's perfectly 11 a.m. So we're gonna get right into it. Just some general information before we dive into today's topics. Today's webinar is live. So I'm here and more than happy to answer all the questions that might arise during my presentation. Probably I cannot answer all of those questions, but I promise to take them with me and shoot out an email afterwards with the respectable answer. So it's perfectly 11. We can get into it. Okay, today's webinar is about to start, and today we would like to talk about resource efficient automatic irrigation with and without KNX, and we can do that with Elsner Elektronik solution, our Jardana. A couple words about myself. My name is Bastian Elsner. I'm managing partner at Elsner Elektronik, and my main responsibilities are everything that is going basically outside of the company. So all the product development, marketing, sales, purchasing, and logistics. We start with a quick introduction video about the Jardana. All right, here we go. Perfect. Now we can start with a quick question. Do you think above statement is correct? Feel free to give me a little input in the chat so we can make it a little more interactive. So, do you think watering in the evening is wrong? I wait a couple minutes in case you want to give some input. Okay, I've seen some comments that watering in the evening is supposed to be great. I beg to differ. I don't think this statement is true, and I don't think it's good to irrigate in the evening. The reason for this is when the when the soil is very hot, the water will evaporate and it will not reach the roots. This is happening if you irrigate in the evening and the soil is still hot from the day's warmth, or even in the afternoon. So there's definitely a better timing to irrigate your plants and to water your garden. So when do you think you should be watering your garden, or what is the actual best time to do so? I gave you a couple possible answers, and I would be very much interested to see what you guys think is the best time to actually irrigate the garden. Okay, thanks for the comments in the chat. I've seen some right and some wrong answers. Let's get into the solution. So, ideally, you should be watering your garden very, very early in the morning. Some would even consider this night. So before the sun rises, this is very crucial in order to minimize evaporation and to ensure efficient water usage. And that is exactly what today is all about: efficient use of the resource of water. So, therefore, in today's webinar, we will be discussing how to optimize the watering of different plant zones, also how we can utilize the optimal watering time without needing to get up super early in the morning or to stay up very late in the evening. Also, how to save on water costs and how to optimally configure all the functions that the Jardana has on board. Let's have a look at our agenda for today. So first up, we're gonna discuss the functions of the Jardana. Afterwards, we will take a little closer look at the installation and the connection capabilities of the system. Next up, we will look at the irrigation system itself and how to optimize the irrigation in your building automation project. Next up, we will take a look at the mobile Jardana app. Afterwards, we will have a quick look into the ETS application. And next up, we're going to discuss various parameters that you can use to make a really, really nice automatic irrigation system with our Jardana product. Last but not least, we're gonna discuss different application examples, also how you can use the Jardana in combination with other KNX products to really leverage automation systems in the garden or in the greening area. Perfect. Before I get right into the topics, into the functions of the irrigation system, I will make a super quick pause just in case someone has a remark. If you think we forgot something on the agenda, feel free to request now and I will make sure to take some time in the end to discuss the points that we have not been mentioning in the learning goals or in the agenda. We will continue in a couple seconds. All right, no more remarks. In case something else comes to your mind, please remember we are live today, so just shoot out your questions. Here we can see the product Jardana, which offers the following functions. So firstly, we can irrigate 4 zones according to a timer or to the measured soil moisture value. This is going to be very important, but we're going to discuss it in more detail later on. You have the connection options for the soil moisture sensors, and the device can be used via the app or via KNX control via the objects. Supply voltage are via power supply unit, and this is included in the scope of delivery. So our product is basically plug and play. So essentially, the Jardana control system is all about targeted garden irrigation of 4 different planting zones. The measured values are supplied by the optional sensors. They are optional. You can even use them with timers, or you can use them as the sensors as they are. What I think is really cool, the system can also be used with the app alone or with the KNX system. So in that sense, you have the choice. Let's have a look at the soil moisture sensors. Our soil moisture sensor makes it possible to measure the moisture in the soil. By setting a moisture threshold value, automated irrigation can then take a place. It is also possible to connect up to 4 different soil moisture sensors to one Jardana. This is really cool because then you can use real-time data for different irrigation zones. In the next chapter, we will have a closer look at the installation and the fitting of those devices. In the photo on the left, the Jardana is shown. This can be attached to the wall with 4 simple screws. I recommend using the wall bracket as a template to mark the 4 drill holes. This is quite a neat little trick for installation, but I'm sure many of you know this trick already. We recommend a mounting height at least 50 centimeters above the floor. To open the Jardana, the side screws that you can find on the right and left hand side in the top hand corners must be loosened. Then the cover can be clicked and removed. The inside of the Jardana will look like this. You can recognize the 4 individual valves, the pipes, and the electronic box. So the whole KNX part is in the little box in the middle. The picture shows the recommended cable routing. So the cables for the soil moisture sensor, the power supply for the Jardana can be seen here. The KNX cable is shown in green, of course. To open the electronics unit, you need to remove the dummy plug, insert the supplied cable gland, and run the KNX TP cable. The KNX connection is located inside the electronics unit. This is where the KNX cable is connected to the KNX terminal you can see in number 1. You will also find the KNX button for assigning the physical address. It is not possible to supply the electronics of the Jardana with the 24 auxiliary voltage from the bus, since the magnetic valves require 24-volt alternating voltage. The cables should be laid as shown in the following instruction. So at the bottom left, you can find a fastening for the cables. This can be found down here. Here's another overview of the cable routing and the connections that you are needing for them. We have now seen all the connection options for the Jardana. I'm sure you can remember them, but if not, absolutely no worries. Since you are either live today in today's webinar or you have been registered and you couldn't make it because something else happened in between, absolutely not an issue. We will send the entire presentation in PDF form afterwards. So if you have the pleasure of installing a Jardana anytime soon, you can use the presentation as a little cheat code. So let's go through what we have learned in the past couple slides. So we have learned about the following connections: how you have the option to connect the TMI soil moisture sensor, which are optional, how to connect the KNX bus, and how to organize the cables and attach them to the wall bracket with cable ties. Before we get into the water connection, I will do a super quick break just to scan if there has been any questions coming up. Okay, one really interesting question arose, and it is the following. So I'm working on an existing KNX project. So in this building, there is already KNX installed. So the question is if the Jardana can be also integrated into the KNX network as a later stage. Yes, of course, this is possible. The only thing you need to do is to have the wired connection via KNX. There has been another question coming up. If the device is supporting KNX Secure, it is KNX Secure ready, but it has not been updated to KNX Secure capabilities. This is something that will follow with the next revisions. Unfortunately, I cannot give a timeline for this as of yet. Thank you very much for the interesting questions. I will continue with today's presentation. In the last portion of the presentation, we had a look at the cable management for the KNX wires, for the sensors, and now we're going to have a look at how the water piping is working. So it's very important that all the screw connections of the water supply are be checked and that they are hand tight. So it's really, really important that you check them afterwards. Due to transportation, due to some vibrations whatsoever, they can loosen up, and it's of utmost importance that you're checking those once you have the system installed. So you can connect the different hoses to the different connectors that we're supplying with the Jardana itself. So really plug and play is becoming a new meaning here. All the standard water plugs will be working with our system. To continue the commissioning, the LEDs are used to display the Wi-Fi connection status, and this can be used also for diagnostic purposes. So the LEDs are located on the top of the housing, and it's shown in the blue circle. The Jardana can either operate in access point mode or to be integrated into an existing network in station mode. In access point mode, the device can also be used in remote gardens where Wi-Fi is not available. The Jardana can use a 2.4 GHz Wi-Fi connection. In the first 60 seconds after starting, you can connect directly to the device regardless of other settings. If no connection is established within this time window, the controller automatically will switch to set mode. This is what the control unit looks in reality. So, plug in the power supply on the left with approx 1.9 meters of connecting cable. Further to the right-hand side, the connection for the water supply in the upper area. In the center is the electronics control box. And further down, the controllable water connections are the 4 planting zones, respectively the 4 magnetic 24-volt valves. The photo on the left-hand side shows our TMI sensor, which you can order with the Jardana. This one measures the moisture in the ground. It's very important that this one is placed well. Well placed actually looks like this. So for the optimum near surface measurement, the sensor should be buried horizontally in the ground. The housing in the green measuring surface must be completely surrounded by soil without any air gaps, because this will hinder us from giving out correct measurements. This is the only way to correctly measure the soil moisture. So the probe must be placed with the narrow edge facing upwards in order to obtain an optimum measurement result. When measuring in a plant container, a distance of at least 5 centimeters should be given from the edges of the container. There is many different ways how you can place the sensor in a not so good way, in a wrong way. So for example, here you can see a wrong placement. So if the sensor is sunk into a hole and this is loosely filled, water can seep into the filled area more quickly and the measured values are not longer representative of the surroundings. And the same with air gaps. Another example for a wrong installation is the following. So if water collects on the measuring surface, the measurement will be wrong. Therefore, the probe must be placed with the surface facing upwards. It's very small details, but they are very, very important in order to realize a resource-efficient irrigation system. Also, another very, very important fact about how the entire system is actually working. I'm sure this is going to be addressed in another part in the presentation, but I also want to add this within this one. Our Jardana will never start the irrigation if we give out the value there's a very low moisture content in the soil. Let it sink in for a second. This is quite important. Because our Jardana and the sensors are only there to prevent watering if it has been rained before. So this is quite important. Our soil moisture sensors will never trigger an irrigation. They will always only avoid irrigation if it's not absolutely necessary. And this is exactly where you have the great lever for resource efficient garden automation with our Jardana. As mentioned, I'm sure we will go over this very important topic over the course of today's presentation. Once again, I do a super quick check if some questions came up. That was a lot of content, and we continue in a couple of seconds. Okay, thank you very much for all those questions. I try to go over them as good as I can. So there has been one very interesting question. Is it possible to operate the device using APIs to predict rainfall over the next few days? So this is not possible with if you don't use KNX, but if you use a respective visualization where you can integrate the objects from the Jardana, it is possible to use predictive weather services in order to control the irrigation system. This is not a capability that is in the ETS file of our Jardana, but this is something that can be definitely achieved with a little bit of engineering and system integration capabilities. There has been a question if there is plan to release this device on 5 gigahertz as well. As of yet, there is no plan as such. There has been another question if we could tell more about the KNX gauge, which we have also in our catalog for use with the water tank. I won't be answering this question as of now because this is actually one of the examples of the use cases we're gonna discuss later on. So there have been many more questions than that, but I don't, if I try to answer all those questions, we extend too much time of the webinar. So some of the questions we will also answer via email. Thank you very, very much for the interest and the exciting questions. Let's get back into today's presentation. So now we talked about the installation of the TMI and the soil moisture sensors. This slide I should have probably shown before. We just did a quick question session, so I think I can skip that one. Let's get into the third chapter of today's webinar. I would like to discuss optimal irrigation. So in the chapters before, we had a look at the connection and the installation. In the next section, we will learn about the different irrigation systems and how we can irrigate optimally. So let's start with the areas of application. First up, it can be a garden at a single family house, but it can also be a bigger garden plot due to the possibility of own Wi-Fi or AP mode. It can be also used for a more sizable balcony and also good for self-sufficiency in vegetable gardens or greenhouses. The Jardana can basically help everywhere. There are different types of automatic irrigation system. Here are the most common. Firstly, you have the drip irrigation. It is quite precise of water using small drippers directly to the roots of the plants. The advantages are quite clear. It's a targeted irrigation, you have quite a low evaporation, and you have very little weed growth in comparison to other irrigation methods. Next up, you have the sprinkler systems. So the use of the sprinkler system heads to even distribution of water over larger areas, for example, for grass. Installation is quite easy, efficient for the irrigation of lawns, as mentioned before. Next up, you have the, I would say, proper irrigation systems, where you have the water distribution via pipes that have spray heads or nozzles, and they are mostly used in commercial applications for fruit trees, shrubs, or larger planting areas. There's another way, the retractable irrigation system, which I personally find very, very cool, but it also takes quite an integration effort in the sense you are required to dig some holes. In my opinion, it's quite important when selecting a system to the specific requirement of the garden and the plants that should be taken into account, because every system can be different effective and can be used in a different type or area of the entire topic. For you to remember, the most important thing is for the Jardana, it doesn't really matter. With the Jardana, we can control all types of irrigation. Okay, when watering from a rainwater tank, it is very important that we ensure a pressure or pumping capacity of minimum 1.5 bar. This is quite important. Another side effect is, for example, that for the Jardana, it's impossible that all valves are being opened at the same time. So it will always work like that. First valve 1, then valve 2, then valve 3, then valve 4. This is due to the average water pressure that is coming out of the pipes here in Central Europe. Lawn sprinklers, as mentioned here, often require a little bit more than that. Exactly what I just mentioned. It's only possible to open one valve per irrigation cycle. Let's get into the tips. So depending on the species and the location, there are major differences in the plant's water requirement. Also, in general, plants in sunny places need more water than plants that are growing in shades. This is some very basic tips, but they can be simply automated with the use of the Jardana irrigation system. Also, irrigation time is quite important. So, irrigation should be done at least by 6 a.m. in the morning, the latest. If you do it in the evening, as we had in our introductory slide, the moisture will evaporate due to the heated soil and cannot be absorbed effectively. This is everything but not a resource-efficient building automation. Another tip to counteract this is actually also to cover the plants with some filling material like mulch or some other devices like small branches from trees, for example, that just help to store the moisture within the soil. Okay. Before we dive into the next chapter, the Jardana mobile app, where you can see the control capabilities firsthand, I will do a quick screening of some questions that might have popped up. Take some time to read them and answer them. I'll be back in a couple seconds with you. Okay, thank you very much for all those questions. I just pick out a couple. So is there any way to track the water consumption of an irrigation system? Unfortunately, the valves that we are using, they don't have any measurement capabilities, so we cannot measure the flow that is going through each respective valve. The only thing that I can think of on the top of my head is the placement of a counter in front of the system, so before the water actually goes into the system, so you can know how much water is used in the entire system. I know for a fact there are even KNX water consumption measurement devices. You can have a quick look at Ling & Janke. They have very, very fantastic products when it comes to that. But unfortunately, our product does not have this capability on board. Another question is, KNX RF in pipeline? No, KNX RF is not in pipeline. Let's get back into the presentation. We have just learned how to install the Jardana and how to optimally water your garden, how sensors work and how they are installed. So in the following chapter, we would like to have a closer look into the app and how easy it is with it to set up an automated irrigation system. So the mobile app is for iOS and Android. It is possible to set up to 4 timers per valve. You can also start the manual irrigation with automatic switch off, and the automatic irrigation according to soil moisture can be started with the app as well. If you open up the app, you can see the start page of the app. The A symbol can be seen on the top left, which means that automatic mode is active. If the A is deactivated, automatic mode is disabled. For each valve, we have the option of activating manual watering via the application. So this starts the irrigation, and the time shown in the green boxes elapses once the time has run out. Then the valve is closed accordingly. At the bottom, shown by the droplet symbol, the soil moisture reading is displayed. Here you can find the general settings such as language, switching, and the Wi-Fi settings. We also need to configure here whether we want to use the external soil moisture sensors or not. The following options are available for us. You can either use one sensor per channel per valve, or you use one sensor outside the irrigation zone, for example, for rain detections, or you can use it without the sensors at all, and you're just making use of the timers. The following setting options are available for each valve. So we have the option to set the timers for the valves, but we can also set the humidity limits for the floor readings. We have just learned about the app and its function. Next up, I would like to have a look at the KNX parameters. I just have a quick look at the questions since the chapter of the app was we went through quite speedy. Okay, there have been a very interesting question. So what should be considered regarding frost? Are there precautions that must be taken before the winter months are beginning? Okay, we have one functionality in the app, in the mobile app, which is called drain valves. So that let all the pipes run empty. And this is a functionality that we have that you should start before the cold months are commencing. Another in detail question about the pressure that is coming out from the water source. So the question is, do I need a pressure reducer when using drip irrigation? Okay, since the Jardana is operating in a pressure range of 1.5 to 10 bar, drip irrigation usually requires just 1.5 bar. So yes, that actually would be very much recommended to use a pressure reducer if you're just using drip irrigation. Thank you very much for the questions. I really love how interactive this is today. Okay, let's dive into the KNX parameters. So let's take a look at the KNX Jardana settings below. On the left-hand side, we can see all the Jardana setting options. So the general settings and the valve settings. Most KNX systems integrator are familiar with the general function, which is why I won't go into them in so much detail. I would therefore now like to just look at the settings of the valves with you, because this is the special portion of the product. So in the first setting, we have the option of specifying whether the receive times are retained after programming or after voltage recovery. Furthermore, we find two time-specific specifications for manual irrigation and automatic irrigation. This can be found over here. In the next step, we have the setting for the soil moisture sensor. Here we can specify in which cycle and how the measured value is sent to the bus. In the last point, we can set a threshold value for automatic watering. So if the value falls below the threshold value at the start of an irrigation period, the valve is opened for the set time. As with all our new products, we have integrated the context help into this application. So you have the information as soon as you hover over and selected parameter, you can find the explanation in the red box. So here's a question maybe for all the KNX users. How do you like this context help? Do you use it in your recent, current, future projects? What information would you like to find in this context help? you are more than welcome to comment in the chat or give the feedback in the feedback form that we are sharing after today's webinar. From a manufacturer perspective, I know this is a lot of work to integrate this, thinking about a weather station with approximately 6,000 parameters. This is quite a technical marketing efforts that we put into this. So once again, the question for you, how do you like this context help, since I would consider this a relatively new feature? Okay, before we get into this topic, I see two more really interesting questions has been popped up. So one question is, how long can the cables for the moisture sensor be? So we actually have different lengths in our shop. So it's possible to go for a length of 10, 25, and 50 meters, if I'm not wrong right now. But we will see this over the course of the presentation. Thank you for the remarks about the context help. Okay, because we move before we move away from the KNX portions and get, in my opinion, to the most exciting part, the application examples, do you still have some questions about the KNX parameters or objects? Okay, no more questions popping up. If you have some questions later on, feel free to shoot us an email. We are more than happy to give some more information about the product after the webinar. Let's dive into the application example. So in the first application example, we are using 4 zones with different irrigation system or different water requirements. So the irrigation at set times is independent of soil moisture. We just use the manual control via the app to stop the irrigation or extend the irrigation. To implement the functions as described, all you need to do is to set a timer in the app under the valve settings, and the irrigation will then take place according to the desired set times. In the next example, we have 4 zones with different irrigation water system requirements. We want to have the irrigation at set times, and we want to use one soil moisture sensor that can give an input to detect rain in order to block the irrigation. That's exactly what I have mentioned earlier. This is very important. Our soil moisture sensors will never trigger irrigation. They will only hinder irrigation if it's not absolutely necessary, because that's exactly where you have the lever for resource efficient irrigation. So to realize the desired function, you need one TMI soil moisture sensor. This can be installed in a zone in the garden and can be used to detect the soil moisture or to recognize rain. A timer is also configured for the respective channels. So if the timer is active and the measured soil moisture value is below the set threshold value, irrigation takes place. So if the measured soil moisture value is above the threshold value, no watering takes place. And that is exactly where we have the lever for resource efficient irrigation. In the next example, we have 4 zones again with different water requirements or different systems. We want to have the irrigation at set zones, but this time we would like to use 4 soil moisture sensors to measure in the 4 zones. So if the soil in a zone is moist enough, irrigation is blocked there. To realize this desired functions, we need a TMI soil moisture sensor that is installed in the zone in the garden and is used to detect the soil moisture or to recognize rain. A timer is also configured to the respective channel, and if the timer is active and the measured soil moisture value is below the set limit value, irrigation takes place. If the measured soil value is above the limit value, no irrigation takes place. So if you paid really, really close attention, this is not so much different than the first application example that we had. So now you might ask, if I can achieve almost the same, why should I in one project integrate one soil moisture sensor and another project I should integrate four soil moisture sensors? The thing is, if you have different requirements, different water requirements in different zones, for example, you have one flowering bed that is very, very important to the lady of the house, the watering should be really, really on point. This can be very different to the water requirements of the spices corner in the garden or of the lawn itself. So in order to not overwater and kill those beautiful flowers, it's very important to have the soil moisture measurement in each individual zone. And that is where, in my opinion, the biggest lever for automation and resource efficient automation comes in. We need the sensor information in order to control accordingly. The more, the better. In the following graphic, it shows an irrigation control system where a cistern is equipped with the KNX SO250 basic fill level sensor, which has been mentioned in another question earlier on. I didn't answer at that point since we're going to discuss this application example. So a valve can be used to switch between the irrigation from the cistern and the fresh water. So if the tank level falls below 30%, the valve automatically switches to tap water. If the tank level is above 30%, water can be supplied from the cistern. The Jardana irrigates the zones depending on the time and the soil moisture limit value. Next up, on the end of the line, you can see our Fabro KNX. It's our KNX touch panel with IP66 capabilities, and it can be used for manual control and to display the measured soil moisture values, for example. Irrigation can be also blocked as required or in the event of certain events using KNX logic. Party mode, for example. You have an event in the garden, you have guests over there, you just want to block it and don't want to have it. Possible to do in the application, but also, of course, with any KNX interface. We have implemented this example into a KNX project that we will be also sending to you after today's webinar. So you can also have a quick look on the ETS level, how this could look in reality. Maybe just a couple words about our Fabro, since it's a very unique product, the only KNX IP66 touch panel that can be installed outside also. I, for example, have one for my terrace exactly for this use case. I'm also switching the light, also the awning, but also the irrigation of the water. And I'm very happy that I have one control center in the terrace and I don't need to worry about this due to the IP66 certification. Since the device is outside, of course, you can block everything with a code, so no one can just come around, go on the terrace and tamper with your building automation system. So we have 4 zones. We can do the irrigation according to the soil moisture. The KNX control controls the water source, and the manual control is, of course, possible via the app, but also via the Fabro KNX display. Of course, this does not have to be the Fabro. It can be any other KNX room controller. But if you want to have it outside, I would recommend our Fabro. Wonderful. We are at the end of today's webinar. I'm seeing there has been some more questions. One of them is how the SO250 probe works. So this is quite interesting. I love how this works actually, because you have a sender. This is basically the probe. It's an ultrasonic sender. And what they're doing, we're putting them on the top of the tank, as you can see here in this example. So you put it from the top. We send down an ultrasonic wave, and this ultrasonic wave is reflected by the surface of either oil or water, for example. So this is not only usable for a cistern, you can also use this for an oil tank. And that's how this measurement works. We are basically measuring the time. How long does the ultrasonic wave take to be reflected from the water or oil surface, go back to the sensor? We are measuring this time, and according to this time, we can calculate how full the tank is in which our KNX SO250 is installed. Next question. Is it possible to know the capacity of the tank? Yes, this is possible. You can also put different geometries of the tank. So if it's a round tank, if it's a tank that is more like a big tube, that really depends on you. I think if I now open up the ETS and go into the SO250, then we are using way too much time. So if you would like to know more about the SO250, you're more than welcome to reach out to me or to some technical colleagues. I will give a contact in the end of today's webinar. So feel free to send an email. I'm more than happy to explain more about the product. Okay, no more open questions that I can see in the chat. So once again, thank you very much for attending today's webinar. It was great for me to have so many questions. So I did not only had to read my notes the entire time, could also answer some questions. I like the more interactive it is, the more fun it is to hold those webinars. So thank you very much for being such an interactive group today. Appreciate all of you guys being here. After the webinar, we will send out a quick little feedback form to the email that you have used to register to today's webinar. I would be super happy if you could give me a feedback for today's performance. For myself, if the content was good, if you understood anything, if you would like to have a deeper dive into the technique, if you want to have more ETS, less ETS, if you would like to have a webinar about a product that we haven't done a webinar as of yet, this really helps us to take Elsner Academy to the next level, and it would not be possible without your feedback and the input. So I kindly ask you to take the feedback form seriously and let us know everything that you liked, that you disliked. I'm even more interested in the things you disliked, because that's the only way we can improve. That much from my end. I really hope you enjoyed today's session. I will remain in the call for another 2-3 minutes in case more questions will pop up. Presentation and recording will be sent to your email afterward. We will also upload this recording on YouTube and on our webpage in case you would like to forward to a contact, to a customer. We are here. Okay, thank you very much for your attention, for your time. I say goodbye already and wish you a wonderful remaining week. Spring is just around the corner. Spring is happening. Summer is actually just around the corner. So irrigation comes also more pressing. Looking forward to have individual conversations with every one of you, and hopefully we can help to position some Jardanas in future building automation projects. Thank you. Okay, there has been one more question about the API. I tried to answer this one earlier. So there is no open API on board for our Jardana. The only way to integrate this into another system is via KNX.